Good morning. Today, I will tell you something about the angle of squint and how to measure the various methods available for us. I will share my screen now. Taken already 3 classes about various aspects of squint. And I told you about cover and uncover test. And I just mentioned about the various types of squints like concomitant and incomitant squints. Today, I will tell you about the various methods available for us to measure the angle of squint or angle of deviations. All of you may be knowing here that the left hand, this picture, I'll show you the picture now here. This picture, patient has got left eye exotropia. Here, the left eye esotropia. That means what now? These are all the squints, horizontal squints. Okay, we can have hypo, like that. The eyeball can go up also, can come down also. That is, these are all tropias. By seeing outside, I know the patient has got squint. Whereas the other entity called phoria, that is a latent squint, you have to bring it out. We have to do some tests. So we can bring out the latent squint. Now we can see now here, when I put a torchlight, it's called, this test is to find out the angle of amount of squint or the angle of deviation or the angle of squint. This classical test, of course, everyone knows, is called Hirschberg test. Hirschberg test. What it is, you put a torchlight in front of the patient, observe the corneal reflex. And if the corneal reflex is seen in the center of the pupil in both eyes, that means the patient has got no squint. The same thing, the corneal reflex is present, suppose in his left eye. It is in the margin of the pupil, or it is in between the margin and the limbus, or in the limbus itself. So when the torchlight is the position where the torchlight, the reflex is falling, you can tell approximately this will be the amount of deviations. How to measure now? Just know this. 1 millimeter shift, 1 millimeter shift of the reflex from center is approximately 7 degrees. For example, imagine the diameter of the pupil is 4 millimeter, for example. And if the from center, the reflex is falling in the margin, this margin, that means what from center is margin, about 2 millimeter. So 2 millimeter shift is there from center. So 2 into 7, about approximately 14 degrees. That's why we tell when the pupil reflex, or sorry, when the reflex falls in the margin of the pupil, we take it as 15 degree of deviation is there. Suppose the reflex falls on the limbus. You know, the diameter of the cornea is approximately 12 millimeters, horizontal diameter. From center, it's about 6 millimeters. The limbus margin is 6 millimeters. So naturally, 6 into 7, how much now? It is 44, 42. That's why you approximately tell there is a 45 degree of squint. 45 degrees of squint is the patient. So that means what? When the reflex, corneal reflex falls in the pupillary margin, approximately 15 degrees of squint. When the reflex falls in the limbus, we take it as 45 degrees. If it is in between, the pupillary margin and the limbus, we take it as approximately 30 degrees of squint. But remember, we are telling everything in terms of degrees. By chance, it does a prism diopter. If you want to tell, 1 degree is equal to 2 prism diopter. So if that 30 degree of squint is there, it has to be 60 prism diopters. Is the way you tell the examinations. Even for your patient coming with squint, when you are measuring the angle of deviation, you just use this method. For exam purpose, you must know this. At least you should know. Here, one tricky point, suppose the pupil is only 2 mm diameter. And from center, the pupillary margin, the reflex is falling on the pupillary margin. Don't tell immediately 15 degrees. You know that is 2 mm diameter. So 1 mm shift. So only 7 degrees. Whether you must tell the exams. Don't always think pupillary margin is 15 degrees. It depends upon the diameter only you have to consider. One more test you can find out the deviation. You got prism bar cover test. Cover, see the eyeball is coming straight. That means when you cover the left eye, that squinting eye comes straight to take a fixation. What's the meaning now? The squinting eye has got reasonably good vision. I'm now putting a prism bar. Always remember, in this case of the eyeball is inverse, always remember the apex will be looking at the deviation. But when I tell in terms of prisms, I will tell base out prisms. This is called, when I put up, always remember, the apex will be looking at the deviation. Here esotropia, apex is inverse, so base out. When I tell you we are going to put a base out prisms in front of the squinting eye, and a cover now here over 40% diopter is there. I cover, the eyeball still is moving. Imagine now. That means we keep on increasing the power of the prism in front of the squinting eye to arrest the movement. That is what of aim. See, now we are 50% diopter. Here also the eyeball is moving. Eyeball was moving. When I cover the normal eye, see 55, cover the normal eye. Eyeball is still moving to take up fixations. So naturally, this is a way you have to find out. You see now in this case now, we are putting 60% diopter. You cover the left eye, the eyeball is not moving. That means what is the meaning now here? With the 60% diopter in front of the eye, the light rays are passing through the prism. They are going to be brought to your focus on the fovea of the squinting eye. That means there is no need for movement. Only when the rays are falling outside the fovea, somewhere not in the fovea, the eye is moving to take up fixations. Whereas if it is falling on the fovea, there is no need for movement or moving the eyes. This is what the basis of this test. We are finding out the angle of deviation by putting a prism in front of the squinting eye, and you are placing a cover test, or you're doing cover and cover test in the normal eye, and going to bring out. It's called prism bar cover test to find out the angle of deviations. Please remember, I am putting prism in front of the squinting eye, and you are covering the normal eye. That means our squinting eye should have reasonably good vision. Then only you can proceed with this test. There are some more tests also. We got Krimsky's are modified. Just know it's Krimsky. What is the meaning here? In this case, if you carefully note this squinting eye, you are placing prism in front of the squinting eye, and you see esotropia, the apex is inside, the base out. Now you make the eye, move the eye in such a way that reflex becomes straight or center. That's what the idea. It's called Krimsky. But the problem here, we put a prism in front of the squinting eye. What you are going to measure may not be actual reading, because you are going to prism can affect our readings. But modified Krimsky test is done. Modified Krimsky test is done. What for? You are going to put a prism in, not in the squinting eye. You are going to put a prism in front of the normal eye. Same thing is a esotropia. So apex inverse. So base out. Similarly, in the normal eye also put the same thing, base out and then apex inside, base out prisms. What's the meaning now? When you put a prism in front of normal eye, the rays will be deviated to take a fixation. The normal eye will move. When the movement is there, the squinting also will move because of Airing's law. And the reflect that is falling on the limbus here, you have to keep on increasing the power in front of the squinting eye, bring it straight. The amount of prism or the power of the prism with which we have moved or which have brought the reflection center, that is the angle of deviation. But this test is what for? This test is not what done for which patient. Remember now, when the squinting eye has got very poor vision, very bad vision, or some scar is there, the patient cannot see. In that case, I want to know the angle of deviations. I put a prisms in front of the normal eye to bring it straight. Whereas in this test, the eyeball, squinting eye has got reasonably good vision. Then we're going to place. But better option is what always Krimsky means you just tell both. You have to keep modified Krimsky that is in front of the normal eye. Just know this. This is mainly done for when the vision in the squinting eye is very poor. These are the classical questions, how to find out the angular deviations. One is Hirschberg test, another is called prism bar cover test, and we have got individual prisms. The prism bar is made up of plastics, whereas the individual prisms are made up of glass. These are the common questions they can ask in examinations. Hope you have understood something. Thank you very much.